Season 3, Episode 2, Take 1. Welcome to Quantum Kinetics, First Diffusion, Season 3, Episode 2. I'm here with
Jason McCoy.
Jason McCoy, it's so good to have you on the show again. What are we going to be talking about today?
All kinds of cool stuff. Propulsion, some viewer questions, some stuff about video games.
Oh, great.
Some stuff about keyframes, time frames, fusion, plasma.
Hey, what is plasma?
A fourth state of matter, right? It's like when an electron gets knocked off of an atom.
Well, we could talk about that, but first I think we need to talk about the question and answer from the audience.
Okay, let's do it. So there's a viewer with a question that says, can you describe QKW's use of air as fuel versus water? And this is something I wonder too, because when we talked about bringing up propulsion, if you have a flying car or something, or you have a car, or you have a boat, or you have a spaceship, what exactly is it that the reactor is using to create energy or create fuel?
So before we talk about the actual arc reactor's fuel source, let's talk about like conventional prior arc technology fuel. So gasoline is a hydrocarbon, which has hydrogen laced to basically a carbon, has hydrogen on it. And when the gasoline goes into your engine, it has a little tiny spark, which then causes the hydrogens to ignite, causing some type of thermal differential to push the piston up and down. So that's a conventional thrust mechanism for fuel. So to answer the question about the QKW's fuel source, is that technically anything in the universe can be considered a fuel source because of Einstein's equation, E equals mc squared, right? Any kind of mass can be turned into some type of energy. And so that's the amazing thing about like a glass of water. A glass of water has enough atomic energy to heat a home for one individual for their entire lifetime.
One glass.
One glass. Yes.
Why is that? Because the E equals plus or minus mc squared?
Correct. The energy in the form of mass, so like frozen plasma. So like Dana Kipple says that, and we kind of agree with that, is that the mass is frozen plasma. And plasma could be electrons flowing or whatever, but like essentially the energy that is in matter is enormous. And then that's how we have nuclear bombs, that principle where energy can be turned into mass or mass turned into energy, that kind of a thing. So with the Quantum Kinetic Well technology, what we do is we create a very special type of electricity that sucks in the mass, the electrons, and turns it into electricity, if that makes sense, right? So if air has electrons in it, we can turn the air into electricity. We can turn water into electricity because there's electrons on water, right? And we've also found that we can do this in a vacuum as well. For some weird reason, actually the amplification of the resonant circuit works better in a vacuum and everything else. So the answer to your question is any fuel that has mass can be turned into energy.
So just to follow up on that, is that I think when the conception of like a fuel is something that you burn, that's a chemical reaction, right? But a different level of that reaction, to take any kind of like air or water or whatever and turn it into fuel, are you breaking apart atoms to do so, or are you stripping electrons off of the atoms that already exist?
Both.
Yeah,
so you're in the circuit when it's pulsing, the arc reactor, it's actually causing the well, and it's stripping the electrons right off of the oxygen molecule. If it's doing it to air, it's stripping the electrons away. And as you strip the electrons away from the oxygen molecule or nitrogen, there'll be a cavitation in the localized space, and so there's fusion that happens. Does that make sense? Because when an atom loses electrons around it, it becomes deshielded, and thus it has to renormalize. It's like the normal process of fusion.
Is that the Coulomb deshielding event?
Correct. Very good. It's the Coulomb deshielding effect. Coulomb. And so when you strip those electrons out into the circuit, then the universe goes, well, you took my electrons, I have to fall into a well.
That's so interesting. It's such a different approach to the like conventional reactors, like a tokamak reactor.
They push in.
Yeah, it's all in the magnetic confinement reactors.
They're compressing their plasma balls.
I was going to say that. Yeah. Well,
I stole it. I'm sorry.
That's what's happening, and that's probably why it's not working as well. It's just takes a lot of heat. Like Randall said this in one of the, I can't remember which thing it was, but that's if you take a lot of heat and you take a lot of energy and you take a big, giant, expensive warehouse and you force it, then you can make it happen, but you can't sustain it, and you end up damaging all the equipment around it, right?
Yeah,
the shielding walls, and
right?
all that.
And so if you're pushing really hard into something, you're pushing the electrons, right? Like, so for example, let's just take this ball. Let's just say that this is an electron floating in free space. If I push it, it's going to go this way, right? But if I suck it, it's going to come towards me, right? There's a push factor, and then there's a pull factor,
right?
And so in normal tokamaks, they just push electrons around, and then they squeeze them, and they're like trying to get in, try to get them to fuse and really push them together. But you can see as I'm pushing this, it doesn't really want to fuse, right?
Right.
All the field lines are pushing back at me.
You're almost like invoking the very counteractive force that makes it very difficult to make it happen.
Do you want to know a secret about the Coulomb barrier?
Sure.
It's the antithesis. It's the opposite of gravity.
Huh.
Gravity is an exponential curve. Like, the closer I get something together, the more gravity shows up. The Coulomb barrier, the closer I get, the repulsive factor goes up, just like gravity and repulsive action.
Huh.
So the Coulomb barrier is basically almost the same force as gravity. It's the opposite. It's repulsion.
And like almost like a magnetic force, which I understand is different, but it also, the closer you get to it, the more powerful that force wants to resist. Is that?
Yes, and it's exponential. So the closer to the square root, basically, the closer you get, the more it pushes back on you.
Huh.
So there may be a way to, phase shift the electron. So instead of pushing it, you suck it, and you then create mass, create a new piece of material, just condensed light, and then you turn off your circuits, and then now you have a new thing there. It's a new element, a new atom.
Huh.
And when you do that, a huge amount of radiation occurs, like gamma radiation, X-ray radiation, and these thermal temperatures are the nuclear fusion temperatures that everyone's trying to get in their reactors. So instead of pushing all these watts into your reactor to induce fusion at a low probability, why not just suck the energy out of the reactor and then automatically cause the cavitation to fuse material?
Huh. The vacuum basically is the process that pulls it in and allows it to happen instead of just ramming it together.
Yeah. It's a much more gentle process. It's more of a Mother Nature's process.
Thus, you don't have to force it, right?
Fusion is love, and love is fusion.
Those sayings are making more sense over time. It's so funny because, like, I'm on the podcast, and even I get irritated by that stuff. I'm like, you can't say that hippie stuff. It isn't scientific, but it's metaphorical. It's true that the process is different if you don't force it. Well, in that sense, that is scientific.
Yeah, it totally is. When I first got into this and I started learning it, I had to learn all the basics. I had to learn all the theories and all the math and all that stuff. And what I found is that it doesn't do much good to, it's a huge learning curve to like get up over the crest and then be at that level. And so the way that I look at it essentially is, if you're going to teach like really complex systems, it's actually better just to be metaphoric to people.
Yeah. Analogies, metaphors, all that stuff works. As long as they can connect. Well, ironically too, even with you saying that, I still look for the scientific rationale in that, because when you say fusion is love, you don't have to force it. When you say you don't have to force it, what you're sort of scientifically talking about is the process of creating a vacuum or a cavitational event that basically allows for fusion to happen, right?
Yeah, it's just a new instead of pushing, you're pulling.
Yeah, pulling. Yeah. Yeah,
Like
that's
there's up, there's down, there's
Yeah.
left, there's right, there's, in and out, there's
yeah,
push and pull.
yeah. Harmony and discord.
And music theory.
Yeah,
Numbered notes.
yeah, yeah. No, I really love talking to you about the frequency dynamics that go into this, because the idea that there is some music theory stuff involved in it that allows for the process to happen, like octaves. I mean, in terms of like amplifying something inside of a resonant chamber.
Yeah, right.
And like powering it up until the thing breaks apart, like we talked about with the glass. It's all the same kind of concepts.
It sure is. And when you learn the mechanisms of Mother Nature in a very complex way, you have to bring it down a level to teach people. Like, and I know you have this issue with music as well, like octaves and all these words and stuff. Like people start glossing over. I'm like, I don't even know what those words mean. But
I've done it so many times. I've had people just like start off so enthusiastic, like, oh, you're, like they're happy to meet you. They're so curious about what you're doing. And then like 20 minutes later of you like going into the dissertation of like all the complexities, you just lose them. So that's one thing we've talked about a lot on the educational series, right?
Yes,
These courses that you've created, which I watch those.
Oh, good. Yeah, we just so for the audience, we have a new course selection lectures for you. We have 3 right now, and we're hoping to get as many as possible to teach you guys, and we're really having a good fun time with it. And I hope you guys are learning too, because that gives some context to what these podcasts are talking about as well.
Yeah. Oh, I watched them last night. In preparation for the day today, I watched the podcast and I watched the last episode that we did, and talking with my hands. But yeah, they're really cool. I mean, and quantum, you can understand quantum physics is a legitimately challenging topic to understand.
Well,
but after watching the courses, I feel like I understand it a bit better. Good. I don't understand it as well as you, but it's so interesting to see the graphics and hear your explanation of it.
Well, thanks. I'm glad that you enjoy it, and I hope that the audience enjoys it as well. And it gives you guys context too to kind of follow along with the podcast as we talk about these deep concepts and whatnot. So, and what I want to ask you a question, Jason.
Sure. Yeah.
You are a teacher, and you know about Unity game engine.
Yeah.
Unity 3D.
Yeah.
What is Unity? And my question to you is, are game engines, like video game engines, analogous to like the real world, like the quantum world or the quantum, the classical world even?
That's a great question. And like part 2 of that will be the quantum part of that. Mm-hmm. So a game engine that people use to play their typical video games simulates events, simulates like a rocket firing through the air.
Yeah.
Or the trajectory of a flying object. Or
how does it do that though? Like when you push play on a video game, is there something underneath the carpet that's running that we never see?
Yeah, there's the game engine has a thing called a frame rate.
Okay.
And the frame rate in most game engines, it's at like 60 frames a second.
Okay.
Which is a lot. It's so fast your eye can't totally tell the difference between one frame and the other, which kind of gets back to classical like 2D drawn animation.
Right.
Those drawings would come at you so fast that it all blends together and it looks like a fluid motion.
Right.
But the computer in the game engine is basically saying, okay, if this ball is in the air, I just want to make sure that was on the thing, or this item is in the air and it's going to fall. Well, how fast does it fall per unit of time?
Right. Distance over time, right?
Distance over time. And the computer 60 times a second.
Okay.
Calculating stuff. Where's the item falling? Where is it next? Where is it next? Where is it next? Did it hit something? Boom. Does it bounce off something?
How does it know to bounce off something?
It has a thing called collision detection. And it detects, like if I push on you, like that's moving you, or if I pick up this drink, I'm colliding with it and I'm picking it up. Although I'm not really touching it, which is well, we need to get back to that one. I'm like, that still blows my mind. You've never touched anything? What? I thought I thought I had a few milestones under my belt with that one, but I guess not. Back to back to zero on that one. But
Well, remember what Yoda said in Star Wars is like, you have to unlearn what you have already learned to use the Force.
yeah, that's what's so interesting about all this physics stuff and quantum fusion and quantum theory in general is that it's like understanding a world that kind of works differently than the regular Newtonian world that we live in. Did I get that right? Newtonian?
Yeah, there's Cartesian space, the 3D space, Newtonian physics where you drop a ball and it has basically gravity. And the question I have for you about the game engine, and you mentioned something about frame rate.
Yeah.
And so when you start playing a video game, you log in, and there's a frame rate to the universe, and depending on your internet speed, you can be there at 60 frames per second or 30 frames per second. Sometimes it drops down to like 19 frames per second, and then it's laggy.
Yeah.
You miss frames.
Yeah.
And I'm wondering, Jason, that is there a correlation to the quantum world where quantum tunneling can happen, where the frame rate of the universe gets missed momentarily?
Yeah.
Can you see that in a game engine happening? Have you ever seen that happen?
I think it has happened where there has been examples of like something falls through like what would otherwise be a collider, and it should detect that it collided with it.
Right.
But that object, if that frame rate doesn't happen at just the right way, that thing does fall through. It does sort of tunnel through.
Whoa. So the collider information data, like the collider data, gets interpreted between a frame.
Yeah.
And then it misses it.
Yeah.
That's what happens.
And maybe that's the way, I mean, you tell me, this like quantum tunneling, it makes its way through what would otherwise be a barrier.
Ah, yes.
And also, this is something perhaps you could speak more to as well, is that they're using quantum computers, which I'm totally fascinated by. Quantum computing, I think, is just amazing, to solve things that it actually takes a quantum existence to be able to analyze. You actually have to use a quantum computer to do something that relates to the world of quantum physics.
Do you know how a quantum computer actually works?
This one, I'll try.
Yeah, go for it.
So my understanding of like, it's not a bit, it's not an off and on, it's a qubit, which is basically the spherical presence of an electron, a probabilistic state somewhere around the nucleus. I'm about ready to tie myself in a knot on that one. Go ahead.
Well, that's what it, okay, so you're totally right up to the point where you're talking about the exchange. So in a computer, a classical computer, there's transistors in the computer. A transistor is a switch, and it goes on, off, on, off, on, off. And in your computer, there's billions of them, and they're going rapid fire, and they interpolate information from the zeros and ones to tell the computer what to do.
Yeah.
And that's a classical computer. A quantum computer, what it does is it takes the zeros and ones and it melts them together into this thing called a qubit. It's on and off at the same time. And so when you put the universe in the state of on and off at the same time, making a qubit, which, by the way, in the circuits of a quantum computer, it's just a coil and a capacitor, and that's it. And then they resonate electrons in those qubits that cause the electron to become on and off at the same time. And so that's what a quantum computer does. That's what the arc reactor does. It's the same thing.
Yeah.
And so we're using Mother Nature's processes to induce a super quick thinking. And by the way, I find this interesting. When I was at the university down in Seattle, I went into a professor's room, and he had this place where he was having, and I'm super tangenting right now, but this is totally about the arc reactor.
Good, because I have another tangent off that one. So.
Okay, good.
Okay.
We're going to quantum tangent here. So I walk into this room where this professor's been there for 45 years, right? And he had on the wall all these signals, because he has an oscilloscope, and he has these syringes, and he has these snails. And what he does is he takes the probe and he sticks the probe into the snail's brain,
okay,
into its head, And he watches the signals, like the alpha, the beta, the gamma signals, like he's
Wow.
watching them. And when I saw those signals that were on his wall, it looked just like the X-ray signals that come from the arc reactor.
Wow.
And it just struck me as in like, wait a minute, is the quantum computer, which has the same signals as a black hole, also acting like a brain? Is it thinking
Wow.
and trying to solve something in a qubit way? That's my question. I don't know the answer because I'm just a scientist and I just observe what I see.
Well,
and
we're made of matter. You know, we're made of matter. So maybe quantum things are happening in our body all the time, right? I mean, we are made of matter.
You're a nuclear reactor right now because you're emitting infrared radiation to you are radioactive right now.
Wow, you know, I don't get told that enough in my day-to-day activities. I'm glowing. That's great.
Yeah, you are. Everyone, if you're alive, you're glowing. You're
right. Yeah. I mean, you could see that even on in a practical matter. You could look at that on like an infrared, like those infrared goggles that the
military uses.
Yeah, you can see people in the dark. You can see animals, and they're really glowing red, right?
Mm-hmm.
I mean, they're really glowing.
This is how snakes actually hunt in the dark,
right? Yes, the pit viper. I happen to know about this.
Oh, tell me about the pit viper.
The pit viper is a snake that has these sensors in its like mouth. Not its like its upper lip.
And its nose, like under its nose, or
like along its side of its mouth.
Okay.
And it can sense heat. So if it's hunting at night and it comes across like a mouse, it can tell like there's a mouse over there.
Oh wow.
And it can sense the heat of it because the heat waves, get to it, and it goes, boy, I think there's something over there. It's almost like vision in a weird way. Well, it's night vision in a way.
Yeah, it's like if you were hunting and you couldn't see in the dark, but you could see an animal walking around that was emitting a glow, like a rat, a mouse, anything that has a heart pumping in it.
Yeah,
it's basically a star. You're looking at like kind of a weird pumping star. Even stars pump, by the way. They have a frequency. It's called mode locking. It goes boom, 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 boom.
Stars do?
Yeah.
Huh.
And they go wom, 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 wom. And they have a period to it. So, and our star is a very special star, actually. It's very quiet. It cycles every 11 years. Wom,
right.
Wom.
Which, by the way, we're in the solar maximum right now.
Well, and this is why there's so many great things happening with YouTube. People are posting great stuff about new ideas of quantum, and the collective consciousness is waking up and being agitated and be excited. This is really a very exciting time to be alive on planet Earth, because we're about to make the next leap, I think, an evolutionary state of thinking.
That's amazing. Well, speaking of that, the thing I was going to ask you about, the tangent on the tangent, does the technology of the Quantum Kinetic Well have anything to do, or could in any way be used with quantum computing? Like, can you use the Quantum Kinetic Well to suspend a piece of matter or an atom and then do quantum computing on it, or what? Is there any crossover between the Quantum Kinetic Well and quantum computing?
The answer is yes, but we have to first have a prerequisite understanding of what a quantum computer actually does. Its main function is to solve the problem as fast as possible, which means to go from point A to point B as fast as possible. And by the way, the quantum computer doesn't just make a linear transition from point A to point B. What the quantum computer does is it quantum tunnels to the spot instantaneously. It solves it immediately. Boom, boom, it's just there. And so, like your brain, I can think about the last podcast we did. Right now, I can just think about it, what we talked about, and I'm there now.
By the way, there's a lot of stuff on babies. As I watch this show.
Crying?
Yeah, babies are cute, by the way. That's what Iron Man said, right? Babies are cute.
Well, and I love the fact that people are commenting too and just saying like this great funny things, and it's really fun for us when you guys do that. And by the way, if you have any questions, go ahead and shoot them in the comments, and we will potentially read them in the Q&A section. But this is really fun. And so the quantum computer and how it goes to figuring things out.
Yeah.
if you have a radioactive isotope that's really angry and mad, and it's emitting radiation and screaming and yelling, and if you induce the quantum computer over the top of it, it will break it down with a nuclear fusion and nuclear fission event, and then it will bring it to a calmer state. It's like soothing a baby's cry, giving the baby some milk. It just brings it down a notch to a stable state. When you're up here and you're a heavy atom, you're really unstable and you're really pissy. You ever had a girlfriend just had a really bad day and you're like, honey, I'm just not even going to try, right? You know, you ever had that happen?
A time or two. I have.
So that's what it is. It's like, hey, it's like you give
half
them
the time
flower.
I instigated it, though, I have to admit.
Well, at least you own up to it.
Yeah.
But yeah, so like if you had a girlfriend that was really upset or, you know, having cramps or something, it's like, what would you do? Honey, what do you want? Some chocolates? Do you want a flower? Do you want cuddles? You're like, what is it that you need as an atom that's unstable to become stable? I mean, that's really the best analogy for nuclear fusion is that it just solves it. You know, and that's, people love people that solve problems.
For sure. And just to speak to it more, the side of it is that something that could, like, for people out there who work on quantum computers, does the Quantum Kinetic Well have something to offer them?
They're doing a Quantum Kinetic Well.
Oh,
Quantum computers do the Quantum Kinetic Well. It's
Really?
just at a very, very microscopic scale that they're like, yeah, we can get these things to do qubits and we can hold supremacy and all this
super
stuff.
cold, right?
Well, and that's the thing about their products that are inferior to the Quantum Kinetic Well products is that we can do it at room temperature.
Why is that? Because they always, my understanding of why it needs to be so cold, cryogenic, is that that eliminates noise. Does that?
Yeah, so there's this thing called the microwave background radiation.
Okay.
And even a room that's at 60 degrees, that has some agitation, some Brownian motion, some chaos, right? Even radio waves that are coming from stations nearby or your iPhone that's emitting radiation, they can make the electron wobble in the degrees of freedom. And if you have that next to the quantum computer, a traditional one, it'll interfere with the circuits trying to make the qubit. So they have to bring the temperature way down. They have to slow the electrons down so there's no interference. It basically just, it's like putting a gigantic resistor in a circuit. It just smooths out everything, like brings it way down.
Right.
So that you can interpolate the little spikes, little, whoop, oh, that was a real signal. No, oh, that's a real signal.
Huh.
Not having this craziness. So like when you turn on your CRTV, like those really old ones that have the electron gun in it, when you turn it on and there's no signal, what do you see?
The static, yeah.
You know what that is? That white stuff?
The universe?
That's the cosmic microwave background.
Wow.
The static that you see in the line scan when it's all
That's
fuzzy,
amazing.
That is the quantum vacuum flux and the microwave background radiation is felt in this room.
Huh.
And out in space.
Wow.
Because you can see it when the electrons are shooting off the gun of the CRTV and it's going line scan. As the electrons going off the gun to hit the fluorescence on the screen, it's wobbling. It wobbled and it's all staticky.
Huh. Wow.
The universe is a dynamic wave system continuously all the time.
Everything, it sort of seems like everything we talk about, every other subject also includes frequencies, also includes these wave dynamics. Everything is, you know, like Tesla said, right?
Yeah, he did. He said, you know, if you want to understand the universe, think in wave frequencies and what was the other wave?
God, we should know this one.
I already know. It's like,
waves, frequencies, and vibrations.
yeah, there you go.
Together,
you
we
got
can,
it.
I don't know why that quote is so hard. Of all the quotes, we should totally know. But just to go back to the frame rate thing.
Yeah, the game engine of Unity.
The game engine thing in Unity. Let me turn that question back to you.
Sure.
So yes, in a video game, there is a frame rate that updates the translation, interpolation, rendering, everything.
Ray tracing.
Ray tracing. Modern computers have gotten way, way better at it because they're way, way faster. They got more muscle.
Well, they're clocked at like, you know, not 2.4 gigahertz, but now they're way up at like 4 gigahertz now or something like that.
So I remember when quartz watches came out. This is back in the day.
Whoa, dude, You're dating yourself a little bit.
This is back in the day.
Did it have the tritium like like the hands
You
on
actually,
it?
that kind of watch is kind of like it.
Yeah,
Actually.
this is like
That's
the
old
cap
school.
of the G-Shock, the old school one.
That is.
School.
I actually like the even more old school. I like the one with the clock, the actual hands and stuff.
Oh yeah.
But so the big thing about that was they said this quartz crystal inside of this watch has a frame rate or has a oscillation rate so fast that the degree of accuracy of telling time over like a year, it's only off by like a fraction of a second or something. Okay, that's that,
wild,
right?
yeah.
But then since then, they've created even better atomic clocks, right?
Yeah.
This is shout out to Randall because I know he's into atomic clocks, right?
Yeah, it's like a hydrogen clock or something, like a maser clock or something like that.
So does the universe have a frame rate? And are you manipulating that frame rate to try to get something to sneak in happen in between?
This guy over here.
I'm going somewhere with that.
Yeah. No, the universe is exactly like a video game because it actually has a frame rate, and it's set. The universe's frame rate is the Planck's constant, which is h bar, which is like
what is that?
H bar. Okay, so when you get to the ultraviolet catastrophe, which there's a lecture and that will be pinned up in the corner here.
It's like a super fast frequency, right?
It's a super duper fast frequency. We're talking like it's like 6.2 or 6.3 times 10 to the negative 34. So that's 34 zeros after the dot.
It's fast.
It's so fast and so like fine granularity between the frames that the odds of a quantum tunneling event, like for example, if I take this piece of aluminum and I drop it on the table, it doesn't go through. And if I keep dropping it, and I drop it like a trillion times, and I just keep dropping it, it will not go through the table after a trillion attempts.
But what about a bazillion?
But if I do it a bazillion times, one of those times it will go right on through.
Wow.
I'll have to sit there for like lifetimes.
And it will, so it will go through it, but it won't, will it do total annihilation? Would it do total?
Ooh, good question. I would say that it would just go through it.
It falls through it.
It would just fall through it.
Not because even total annihilation takes two things really touching. Right?
But technically, this is actually kind of an annihilation event too. It's emitting a sound wave. It's the lowest grade annihilation.
It's bumping into it.
It's bumping.
The magnetic fields are point
and electrostatic.
Okay.
There's electrostatic and magnetic fields of the mass atoms itself, and they hit the table and they release energy into the world. That's E equals mc squared.
So, with the ability to tap into the universe's frame rate,
yes,
and the quantum kinetic well.
Oh boy, here we go.
Are you somehow able to get things to behave differently because of the sort of time-space distortion in that environment?
Yes. What we've seen in our research, Jason, is when you put in uranium-234, 235, 238 in the reactor and you turn it on for 24 hours, the uranium goes away by 80% and it turns the uranium into tungsten, thorium, and lead, which basically means it's going through a time dilation going forward in time. It's going 40 million years forward. It's
decaying?
It's pushing, it's decaying fast. Like if I have a piece of uranium like this, it's like in my hand, and it's beta decaying, it takes 400 million years for this uranium to decay into a half-life, which means whatever the amount of radiation is now, 400 million years, half of it will be gone, the radiation. So we can make this thing speed up into the decay process. So the frame rate of the universe, now we don't know because we'd have to do more science and maser technology science to see what our reactor is emitting to see if it's going forward or backwards in time, which brings up a very good question. Do you have to go back to the future, or do you go to the future to go back?
I have another sort of nuanced question about that. Or, okay, so my question to you is, are you actually messing with time, or are you just facilitating decay? You know what I mean? The distinction I'm trying to make is, like, are you applying energy to the uranium to make it decay, or is there actually a time thing going on?
I would say both.
Okay.
And remember how we talked about in the beginning, it sucks the electrons away and puts them into the circuit, and then the universe has to renormalize.
Right.
This would imply that time is associated with electrons. Right? If you pull electrons away and put them into a circuit and they phase into something else, into a transformer or something, and now you're left with a depleted electron density, and then the uranium falls apart, maybe the time that's holding the universe together in that game engine, the update function of the video game, I missed those frames because you took them away, thus quantum tunneling will occur.
Huh. So interesting.
Possibly.
It's so interesting how many times that physicists, quantum physicists particularly, talk about pulling in stuff from the universe. That like blows my mind. Like, you create a vacuum and then the universe tries to fill it. Where is it filling it from?
Yeah, and there's this thing that Paul Dirac back in the 1940s got a Nobel Prize for. It's called the Dirac Sea, which essentially is this infinitesimal infinity energy, negative energy base. It's basically the one big electron, essentially.
All over the place, all over the universe, always accessible, and you can just pull things in from it if you create the right circumstance.
And that's where these people like, Ken Shoulders and all these other guys, that they have this idea about the vortexing swirling action to cause, an ether knot, to cause a matter to come into existence, thus manipulating time itself, right? And here's my postulation, is that the electron itself, one single electron in its update function, let's just say you have one single electron in the out in space all by itself.
Okay.
Or it's just there. The frame rate of the universe is really fast out there, and I age faster out in space. And we know this from science and all that. If you take an astronaut and you go out into space, they age faster than if they're on Earth, because Earth has more gravity. So gravity seems to slow down time.
Wasn't that Interstellar's thing?
Well, it's based on a movie, yes, but it's also based on two NASA scientists who are twins, two guys.
Oh, yeah.
Excuse me, one guy went up into the space station up in the high.
Kelly something or other.
Yeah, I think that's his name.
I can't remember that.
We'll look him up.
Yeah.
But yeah, the two brothers, they did an experiment, and the one that was on Earth aged slower than the one in space. And my postulation is that when you have electrons that are condensing together, you're changing the Bessel function speed, and it's slow. It takes a certain amount of time for it to update 1, 2, 3. But in empty space, it's 1, 2, 3, 4, 5, 6, 7. It's super quick.
Yeah.
And so that's my postulation. Again, that's what I think, time dilation. And my question is, if you can create an artificial gravitational flux and point it somewhere, like a lens, could you point a gravity field so like a pinpoint out in front of you and basically make time stop? But all the electrons that would do update function, all the protons that do update function, all the neutrons that do update functions, it would just freeze. And that would be a portal of negative energy mass where I just go, well, I'm going to pull through the ether. No resistance, potentially. This
is like UFO spaceship kind of stuff, right?
That would be like, there are some people that have come out of like S4, like Bob Lazar and whatnot that talk about these things. But
what's S4?
Area S4 is a derivative location next to Papoose Mountain, next to Groom Lake, which is a hangar bay called S4, and that's apparently where the sport model UFO is. That was a gift to the American Navy military for testing.
This
again,
is
a theory.
Stuff, like
it's kind of in the ufology and all that stuff. Like,
we talk about it a lot on. I mean, I turn on the news all the time. There's some guy testifying about UFOs. I mean, it's not even kooky science anymore. It's just like you got military guys falling over themselves to talk about it on committees and whistleblower stuff all over the place.
There was I remember watching like a TikTok feed or a Instagram feed or something, and this guy he lived near Area 51. I think it was Nevada somewhere, and his next door neighbor worked for the base, and the guy that was on the TikTok feed was always like hammering him, like, "Hey, you work on the base. Tell us about aliens." He's like, "No, I'm not going to tell you anything." So he knew something. And then one time he got really, 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 really drunk on a New Year's Eve, right?
Isn't that the way all these stories?
And then this is what he said to his neighbor. He said, "I'm going to tell you a secret." And this guy is plastered. And he goes, "Do you know how the UFOs work?" And the neighbor was like, "I don't know." He's like, "UFOs suck electricity out of the vacuum of space." And when I saw that, I said, the first thing that hit me, the Quantum Kinetic Well? No.
Well, if you have access to pulling in energy, and there's an infinite amount of energy,
yeah.
I mean, why not? And why not use it? You're gonna like this transition for flying cars, or regular cars, or super cool speedboats, or spaceships. So let's talk about propulsion.
Let's go for it. Let's jump in.
Last show,
we got 20 minutes. Let's jump in.
Last show, that's it?
We got 20 minutes.
Oh man, this goes fast. Okay.
So you want to know about how the Quantum Kinetic Well can be used in industry for humans on Earth. And flying cars, for example.
Propulsion, travel, how does it apply to that stuff?
Mm-hmm.
And I guess particularly, let me set the stage here.
Baby?
Okay, yeah, set the stage. On one hand, I see a lot of videos on new batteries. So energy storage is a topic.
Yep.
Then I see a lot of videos on new types of electromagnetic engines. Some of them don't use rare earth minerals. Many of them have these unique sort of like a chevron configurations in terms of the way the wires are wrapped. So so better engines, better energy storage, and then like exotic propulsion, like pulling yourself through the air.
That would be. Well, what about ion drives?
Ion drives, in deep space they use ion drives. What's
the fuel source for the ion drive?
I believe it's noble gases like xenon.
Okay. And so what they do is they use really high voltage, and then they induce the gas, which then causes a huge amount of ionic thrust.
Right. It shoots it out fast.
Okay. And so, okay. So the first thing about new age technologies that are clean, the first thing you have to figure out is what's my fuel source? You have to pick, and that's just what's crazy. Is like you have to pick a fuel source, right?
Okay.
So right now we pick gasoline. Going back to the beginning of this conversation, we put in gasoline in our airplanes. We put gasoline in our cars. We put gasoline in our, propane in our furnaces. So we pick hydrogen as the fuel source here, because hydrogen has a propulsion type of explosion when mixed with oxygen and an infrared heat signature, like a spark or a fire or whatever. So that's what we choose as prior art technology, and we've done that since the industrial complex. I want to say military-industrial complex, but it's actually the Industrial Revolution, which actually that's a good conversation too. But so you pick your fuel source, and in that situation, yes, that works. But then you have byproducts, carbon, CO2,
pollution,
blah blah blah. So in this situation, now that we have this new electricity, we can actually use it to create resonant situations to fabricate, using gravity, the quantum well, using gravity to condense new matter, like the magnetic rocks that we made. Those are hydrides. And so what's great about a hydride is that a hydride can be used as a brute force, basically thermionic engine. Battery source. For example, it's actually kind of analogous too, because if you take that rock and you expose it to heat, some small amount of heat, it will off-gas hydrogen, which we could put that into our cars, and run on clean cars. Okay, that's one fuel source. We can use it for a battery, right? You take that metal, that hydride metal, and then you put it into a cylinder, and then you put a current on it, and then boom, it makes ions for you.
Okay.
So you have these, and then you can charge it. You can put energy in, take energy out, put energy in, take energy out. So that would be the next level of propulsion systems that are clean. There is another way you can do it too with the arc reactor technology, is you can actually use high voltage, like the ion drives, and cause a explosional thrust into an engine instantaneously with the spark plugs that we have here that are patented. That's another evolutionary state. And then there's another one even after that. And I'm going to hint at it, but I'm not going to give it away because it's basically the repulsor technology. So the repulsor technology, you don't even need a fuel. You don't need conventional fuel tanks.
You don't need to feed it with a giant tank of liquid or gas. But
yes, you do need a gas, but I'm not going to say which one it is.
Okay.
But you don't even need to have a tank. Like, for example, your body right now, the reason you're alive is because you're made of water. You're 80% water. Your body is the tank. You're just your heart knows how to use it, your brain knows how to use it, and if you're in a desert for 3 days, you die without water.
Yeah.
If you can go weeks without food.
Yeah.
Why is it different when you go without water? You just instantaneously die.
Yeah.
It's because water is the key to everything, including Earth's, life. Like, for example, you're 80% water. The Earth is 80% water. Most organic things are 80% water. Why is it this 80% that's so important to life?
80% covered with water.
Oh, that's right.
Oh, but you know what? Out there they say that there's a lot of water trapped in the minerals inside of the Earth's crust too.
Mm-hmm.
In this,
and they're going through transmutation. That's where oil comes from. Wink, 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 wink.
Huh. Wow.
The under the crust there's a transmutation layer going on constantly. And that's where our oil comes from. It's
not dinosaur.
Come on, dude. Dude, we've already
dinosaur
used up
turds or whatever.
Dude, seriously, if you watch like a train go by, like that has a bunch of coal on it, like it's going up to Canada to sell it or whatever, like there's so much coal weight on that train that's so much. That's not dinosaur bones, and no, that's Mother Nature's coal.
Well, you were about ready to get to something super interesting, which you were saying.
I got too close to the sun. I had to veer off.
I know. You can use a gas, can't say which kind, but so like a flying car, does it have a tank of fuel in it, or is it pulling the gas? Is it pulling the air into a reactor?
Just want me to explain UFOs, dude. I know you do. He's trying to get me to do it.
Back to the flying car. I mean, how do we get there? I mean, what is that?
Well, I guess the question is, do you want to use like resonant propulsion explosion thrust, or do you want to use like a negative differential wave crest to drive around? I mean,
that would be cool.
Bro, like there's evolutionary steps to the technology, right?
Right.
Like the ultimate one obviously is going to be, anti-gravity. Oh,
yes.
By the way, you and I should probably define what gravity versus anti-gravity is first.
Okay, so
before we even
my understanding of gravity is that if you have a large mass, this is like what everybody probably thinks, right? And I do too, for that matter. Like, what my understanding of gravity is that the more mass you have, the more gravity you have. But what was the God particle that they discovered?
The Higgs boson?
The Higgs boson. And then they had isn't there some kind of field that they thought like gums up regular matter, and then that's what gravity is? Or
well, there's two theories about gravity. One is the graviton, which is this particle that is gravity. And then there's gravity waves or gravity well theory. And the graviton concept is dog poo-poo. Just throw it in the trash. It's not. That's not how this works. This is not a thing. It's a wave. Gravity is a wave. It's a.
Then why does big stuff have more of the waves?
See, there you go. Now you're starting to ask the questions like, why does a planet have more gravity than a moon?
Right.
Or why does a planet have more gravity than an asteroid?
Or like rather, does it like if you have a brick of gold and you have a brick of like foam, the brick of gold's super, super heavy, right? Yeah. Or lead, super, super heavy.
Yeah.
Is that because the atoms in there are closer together, or there's more of them per brick of gold? Or does the
yeah, dude, you're going for what you just said there is accurate. Like the the amount of electrons are tighter packed together.
Okay.
And then when you pick it up, it feels heavy. Like aluminum, if I have aluminum ring, its electrons are not very packed together, and so it's a very light metal.
The electrons.
The electrons and even the nucleons, like the protons and neutrons, they're aluminum is very spaced out in a very way.
Yeah.
It's kind of like a foam. It's a foam metal. It's very quite light.
So gravity is just the density of the thing?
It's how packed they are together in a geometric way to create the And here's where, going back to the lecture classes we have that we're starting, this is where it's going to start making sense. You need to go look at the Bezel function of the electron, because the Bezel function has an up and also a down. And so when you pack these things together, these wave fronts together, you can actually get a wave to do dissonance wave or amplification wave. And what I would say is that when you pack these atoms together, these electrons and nucleons and all this stuff together in a planet, what happens is there's a dissonance wave that shoots out. It's a negative wave that starts showing up. For example, you asked me earlier during a conversation on the phone, you said, if the proton is so big compared to an electron, why doesn't the electron just fall in all the time? Because the electron's negative and the proton's positive. It makes sense, right? Like if I have a proton that's this big and you have a little electron this big, and this is negative and this is positive, obviously it would just fall in, right?
Right.
Continuously.
Right.
But it doesn't do that. It goes.
And it's not centripetal force that keeps it away.
No, because it's quantum. It's pop, 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 pop.
Oh,
pop,
right,
pop.
right.
It's not doing this. It's going.
And I think you said in that phone call, which by the way, we have phone calls every day. I'm always calling McKane and like, hey, what's up today? What are you working on? Like literally every day. But you said, didn't you say like an electron lives inside of, perhaps?
It's a theory.
Okay.
And the reason I say it's a theory is because when you have a neutron, it goes through beta decay. And it goes through beta decay. What happens is the neutron will turn into a proton, and as it does that, it will release an electron into the world.
As if it was living.
Yeah,
inside.
where did that electron come from?
So, by the way, in one of your your educational series, episode 3, I believe, the last one. By the way, are you
He's
done
got
with,
them all in the back of his hand.
Are you?
Like,
I'm trying to learn all this stuff. Are you done with episode 4? When does episode 4 drop?
I'd like to drop it on Friday in 2 days.
Oh,
or a day and a half.
That'll be so cool. They're really great. McKane explains a lot more stuff standing in front of the whiteboard.
We got people making rap songs now about
I
it.
know. That's awesome, by the way. And it's a pretty good song.
It's so good.
It's a pretty good song.
Shout out.
Yeah. Well, okay, so in one of the educational videos, you say, what is quantum? Okay, so my understanding of quantum is that inside of every nucleus of an like let's just say inside of a proton. Okay, so it's a proton, but inside of it, there's 3 little things in there.
Yeah.
And those 3 things, I know they have 1/3 charge, 1/3 charge, and
yeah. So inside a proton.
Yeah, what's inside of a proton?
What's inside of a proton is you have an up quark and 2 down quarks. And
Okay.
I forget if it's 2 up quarks or 1 down quark. It depends if it's a neutron or a proton.
That's the positive negativeness of it.
Yes. And so the reason they figured this out is because they had particle accelerators smashing protons together and large hadron colliders and all this stuff.
Yeah.
And so when it exploded, and it basically the cat exploded, it's dead.
Right.
You see all the guts everywhere, and you're like, oh, look, it's a quark. Oh, look, it's a gluon. Oh my God, that's what's inside, and there it is. Yes, it's okay to say that the quark and the gluon's in there, but the question is like, if I ripped your guts out, you even Jason anymore? Like, you're gone, dude. Like, you're. I'm sorry. See you later. Like.
So you're saying if you just look at the pieces of it, it doesn't tell the whole picture?
It doesn't. Yeah. If you look at the pieces that are dead of what you just saw, it doesn't matter. It's not actually even relevant to look at the quark and the gluon in that sense, because those are the particles that show up when it dies. Not when it's alive. Like the electron is essentially every single electromagnetic radiation spooled into a resonant harmonic node, like a note. It's a. It's a note. Like the actual electron is a harmonically oscillated resonant note of all frequencies. Because if you take every single wave, like radio waves, microwave, infrared, visible light, ultraviolet, X-ray, and gamma, you take all those waves that have different sizes, and you multiply all those waves into one function, you get a Bessel function. And so my theory is that when you have the wave, and it's this very numbered notes, theory, where you have the wave crest of the Bessel function, and then you have another wave crest Bessel function that's alive, not dead, and when they wave into each other, you get a new wave that has a more positive charge, because they were two negative charges, and they wave into each other, and then they start spinning and dancing like two, when you dance with a beautiful girl, man, isn't that fun, right? You're cheek to cheek, and you got your hand by her hip, and she's got her hand on your shoulder, and it's just this beautiful synergenic, like, energy, like static almost, like something's gonna happen here, right?
And then the nun comes over and
Bible length apart.
Yeah. Keep room for the Holy Ghost is what they say, right in the middle there.
And so that's my metaphoric analogy to how electrons fall into each other to create a proton that has this different charge. And that's why fusion is love, is because when you have a negative and a positive come together, like a male and a female come together, what's the first thing that they do? Is they create a baby.
Yeah.
It's really that simple.
And babies are cute. So says
says Iron Man, they're cute.
Okay, so one other thing, you were talking about gravity, and another question from the viewer is your device exhibiting anti-gravity? So gravity is...
Oh, we didn't even talk about anti-gravity, but go ahead.
Yeah, so when you were explaining gravity, I was saying the gold bar, those atoms must be close together, and you said they're giving off a wave that...
A new wave.
A new wave that is what, gravity? And then anti-gravity would be getting that wave to go the opposite direction or be the opposite version of that?
Right. So they're the negative light that pulls things down into it. Like, this has electrons all over it, right? There's a lot of electrons in there. And so this electron gets pulled to the core of the Earth because it's very positively charged. There's a lot of magnetite crystal down there. It's spinning and causing the gravity wells. And this is being pulled down. And if I drop it, it wants to fall down until it reaches other electrons that repel it. So anti-gravity, and this goes back to the quantum kinetic lecture too, where if you put, like you've never touched anything in your whole life, like you mentioned that earlier. If I put this on my hand, it's basically repulsing. There's a repulsor technology here. Like the electrons of the metal and the electrons of my hand are pushing against each other, and that's called a space charge polarization. And if you look really close, there's actually a very tiny gap between the two, and that's called it's a 0.1 to 0.3 nanometer spacing between my hand and the metal. And the quantum kinetic effects occur right in that boundary. And so the electrons are repulsing this way.
Like two negative magnets pushing each other apart, right?
Yeah, and they're pushing against each other. Now, if I were somehow to push photon energy out of my hand into the metal, like if I were to have my hand start radiating light, a very special type of light, wink, wink, it would start going up. Because the electrons would be repulsed by the gravity around us.
Is that why they sort of theorize that UFOs pull themselves through space and time? They pull themselves, kind of, right?
Yes, and what that is a very special type of lensing. That's actually something you have to have the repulsors in the craft that's inside the belly of the craft, and then on the outside there's a thing that happens. It's called basically light diffraction, reflection, and absorption, and all these weird mathematical computational things that have time dilation involved with it. But yes, you can create a well in front of yourself that's out of phase of everything else.
Wow. It's amazing that we're on the cusp.
Dude, it's already figured out. It's just who's going to get behind and build the thing.
Wow. Well, let's do it.
Well, we got to get the whole we got to get the whole world to like how And this is what's so exciting. And I just want to like say, and we're getting close to closing up here.
Gotcha.
But I want to say, everyone, thank you so much for like your love and emailing and saying, hey, how do we help? You know, we don't have a lot of money, but how can we help? And it just means the world to us that, you know, we're trying to teach you guys and tell you what's possible with the world and explain to you what we've done so that maybe you guys can take the next step with us. And this is a collaborative effort of the global collective consciousness saying, hey, we're going to wake up. We're going to make this happen. And, you know, the more that we teach each other and the more that we help each other, this is just a synergy of love that's going to be, we're all going to eventually be speaking the same language on planet Earth, which is not an actual normal language. Like, it's going to be a language of love, understanding, and around a technology that is going to give us everything we need. This is basically the last chapter. If we make it through this chapter, Jason, as a group, as a society, as even a species, we're going to go into the depths of space. We're going to find out that the universe is actually ourselves and that we are the masters of it, and we can make Nightmare Land or we can make Dream World. It doesn't matter. You get to choose. It's free will. Yeah. And what an amazing world that's going to be, where you wake up in the morning, you have your coffee and say, you know, I'm going to go stop that person from having cancer. Just like that. And just no more cancer for you, or you have leprosy. I'm going to heal that. Like, all the technology is here for you and me. It's here. Repulsor technology, that's just the start.
Yeah. Wow.
And it's all about the frame rate of the universe, the game engine.
That's right.
In the game, and just to close, the game engine, there's also hacks, right? You ever played Counter-Strike?
I have, yeah.
And where you have like the aimbot, where the ray trace automatically goes to the headshot, and you just click the thing, and you cheating. The Quantum Kinetic Well technology is universal cheating in the physics world using antimatter.
Wow.
E equals mc squared is not right. It's E equals plus or minus times square of light.
Wow, that's cool.
Yeah. So shout out to everyone for helping out. Thank you, Jason, for coming on the show. This has been a really fun one. I know we got more to go.
Yeah. We got through like half the things we were going to talk about, but that's great. We got more to talk about another time.
Yeah, we'll save it for the next one.
You bet.
Okay, Jason, thanks so much. Thanks everyone for joining us, and we'll see you on the next one. Have a great rest of your day. Bye-bye.